Now when I made these graphs, I was pretty creative. I know sometimes it's annoying how creative this one was, but I wanted to make sure we looked at everything possible. Okay, so in picture 11, we see that we have kind of this segment, and it's got a black dot on each end. A black dot on each end is significant. It does not mean the line continues forever. The line has stopping and starting points. So first I want us to take a look at the bottom point and write down the x coordinate. Okay. So of that bottom point, as an ordered pair, just estimating, because I didn't have this dot land exactly somewhere, what is the x value for that coordinate? -8. Yes. 1, 2, 3, 4, 5, 6. All right, so 6 is here. Do we want to call that -6, -7? What do we want to call it? -6. All right. So the x coordinate we're going to say is -6. I don't want to write the y one yet. I want us to focus on the x coordinate. So let's look at the other point. What is its x coordinate? Yeah, 2. That's good. All right. So I'm going to come down underneath the graph. I'm going to write the word domain, so that way you remember when you get home what it represents. You always write your domain starting with the smallest value. Our smallest value is -6. So I'm going to write -6. And now I'm going to use less than or equal to x, which is less than or equal, and now we put our greatest x value, which is 2. You might be thinking, why is this different than the graph that had just the 5 points? This one is different because there's a line connecting our 2 endpoints, meaning there are ordered pairs in between these 2 endpoints, and those ordered pairs in between are also going to have x values. So it's all the x values between -6 and +2. Now on this same graph, let's take a look at the y values. Okay. Coming down to the bottom point, I always start with my bottom points. The y value on that, I think, is what Nathan was trying to get at originally when he said -8. So if we look at that and go down 1, 2, 3, 4, 5, 6, 7, 8, it's somewhere in between 7 and 8. Which one do you want to say it is? All right, Aaliyah voted it's -8. Right. Now we look at our top point. What is the y value of that top point? 1, 4? Okay, 4. That works. So then my range, it's a -4, thank you. Our range we always write with our smallest value first, -8. We use is less than or equal, and now we use y, because we're with our range and we're doing our y values. Less than or equal to -4. Good question. How do you know if it's less than or equal to or greater than or equal to? When you have a span of numbers that has a left starting point and a right starting point, you're always going to use less than or equal to. In the page before that, where we had just 1, where it was y is greater than 0, that's where you could encounter a less than or a greater than. Anytime you've got 2 numbers, you're always going to use less thans. Okay, let's take a look at number 12 now. Number 12. It has what we call a parabola. And by the end of this week, you're going to be graphing parabolas. So something about parabolas is that they have a bottom point that may not be defined, and you have to look at the graph and do your best to figure it out. So the bottom point appears to be where I put my red point, right there. And then the parabola, you can see from these arrows, goes up infinitely. The other piece that your brain has to remember is that this parabola is not going straight up, even though it kind of looks like that. Parabolas go up very fast, but they're actually going out very slowly also. So if I were to overextend those black lines just a little bit to overemphasize it, these lines are actually going up, but they're also going out. They're going out to the left, and they're going out to the right. When we talk about domains, you need to ask yourself, how far left is my graph going? And then how far right is my graph going? Because with domains, we're talking about x values. And x values go left, and x values go right. So if we look at our black graph and our overextended graph that I extended in red, if I were a little point traveling along this graph and I were keeping track of my ordered pair, in particularly my x value of my ordered pair, I would notice that that ordered pair goes all the way over towards negative numbers. And even though the graph is going up, my negative numbers for my x value are still getting to be more negative or further from 0. And so this graph goes forever to the left, which we call negative infinity. And if I were to go back to that beginning point on the bottom of the graph and I were to trace it all the way over to the right, and keeping track of those ordered pairs, the x values of these ordered pairs are also getting larger. It's going forever to the right, which means it's going forever to infinity on the right. And so that means that our domain is all real numbers because it's going forever to the left and forever to the right. So I put several drawings up there on that graph, and I'm just going to clear off the graph and have you have a perspective of what I ask myself. I ask myself, with this black parabola, how far left does this graph go? Well, it goes forever to negative infinity. And then I ask myself, how far does the parabola go on the right? Well, it also goes forever to positive infinity. So it tells me that the x values are all real numbers. Any questions on the domain for that problem? Yeah, there's more power in the base than there is up on top. All right, so let's take a look at the range. With the range, we're asking ourselves the y values. So we're asking ourselves of the ordered pairs for this y value, of this parabola, how far down does it go? That's the first thing I ask with range. So I ask, how far down does my graph go? Well, it goes right to the vertex. I'm going to clean up that point. What is the y value of that bottom point on the parabola called the vertex? Well, its y value is 2, because if I were to figure out the ordered pair for it, I would be putting a 2 there. And then I ask myself, well, if I were traveling up on that graph, how far up does this graph go? How far up on the y-axis does this go? Well, it goes forever up to infinity. So the the range is from the bottom y value of 2 all the way up to infinity. And we write that as y is greater than or equal, and I made one mistake with that 2. Hopefully some of you caught it. That 2 should be a negative 2. Y is greater than or equal to negative 2. Okay, so this is a situation where you wouldn't sandwich it between two values. There isn't a low and a top because the arrows go forever up. And so our range is y is greater than or equal to negative 2. Okay, so domain, I ask myself how far left, how far right, and with range, I ask myself how far down and how far up. Those are the key questions to ask yourself. Let's take a look at the oval. The oval is actually the nice one. So domain has to do with the x values, and we ask ourselves how far left does our oval go. Okay, the furthest left-hand point is right about there. What is the x value of that point? Yeah, -6. So we know that that value is -6. We ask ourselves on the other side for our oval, what is the x value on the right-hand side? Yeah, it is 5. And so our domain is going to be -6 is less than or equal to x, which is less than or equal to 5. Now we look at the range and we ask ourselves how far down does our graph go and how far up does our graph go. So we're looking up and down now. We want to know how far up and how far down. I always start with the down because you're always supposed to start with your smallest value. So I can see that the graph goes down to -2 and it goes up to 4. Any question on 13?